All right, hi all. So today, October the 1st, we have a little agenda here, which is going to really focus in on the lovely analysis that Dana's just done on the SAR, I think. Which so here's the mini agenda. I'm sort of refreshing the agenda because we're copying and pasting it but I think you could do with a little bit of a refresh. So I wanted to focus on the key things. The first, I guess, being the most recent results that came in last week, which were for these compounds, and the data have been sort of color coded here. If I can zoom out of that a little bit, but I can't. Okay, so these are the new results here, and of course, we have a couple of compounds that are active. Well, one principally that's active here, and the control compound was behaving itself. So I think we can believe these numbers. Obviously, lots of inactives, and obviously, the best compound still has this kind of, reasonably low level activity that we see with the best compounds. In this case, of about 4 micrograms per mil, which is about as good as we've got. We've had a few compounds with 2, but basically it's about the same. I know that people may not have had a chance to look at these in detail, but does anybody have any, take homes, any obvious things that jump out?
I came up with a compound that combined on the bottom all the good performers from this round, and that may be worth discussing.
Yeah, I mean, I guess just that I was thinking in general terms about some of the things that we've learned here. I guess I was a little bit hopeful that some of these compounds with the pyridine replacement, still with a sort of ortho coordinating moiety, might have retained some activity, but nothing. So we're pretty constrained with that pyridine. That was one thing that came out here, I think.
But it seems like we can put things on the pyridine.
Yeah, true. Yeah, I mean, this guy over here. And these compounds with the build out in this position didn't give us anything good, unfortunately. That was a thing that's definitely worth exploring, but I think that's pretty much a no-no. The 2 commercial amides also were completely inactive. Better that we bought them rather than made them, but still inactive. And so, some of these motifs here with this N alkylation we know is associated with nice activity. The replacement with that ring really kills it. And we have this one slightly unexpected active compound. Unexpected in the sense that, there's still lots of dependency on what else is up here, given that this compound is completely inactive. Kind of interesting. So, I mean, we can sort of fold this up into a discussion of the general SAR, which is the next thing that we can do. I mean, sure, there's nothing wrong with combining what is the best here of the compounds that we've seen, but I think I'd like to sort of try and combine it with what else we've learned from this series so far. So we can skip to that. If there's nothing else that people want to highlight here as learnings. Okay, so here is the main analysis from Dana's redo of the SAR tables. Okay, so I'm going to put you a little on the spot here, Dana, just because this is fresh in your mind, just to walk us through some of the things. I mean, you've very helpfully laid everything out here, but just to walk us through some of what you're thinking about here. Can you just sort of highlight some of the most important things?
Yeah. So I was just kind of going through and trying to fold in the data from the new compounds. I ended up reorganizing a little bit and condensing. So
the green is represent the same compound with matched pairs, and the yellow is proposed compounds that fill gaps.
Yeah. So yeah, I've noticed a couple of gaps just in terms of like a matched pair analysis. So I would say that the caveat that any of these proposed compounds that I have, I don't really expect to break the potency ceiling that we've been having, just because they are very closely related to stuff that we already have. But so that compound in green with the 5,6 aromatic core and the para-toluol substituent, that's actually not been made. But you can see across a lot of the other tables that it actually connects, it bridges some of these other compounds that we have. So I think it's still worth making, even though my guess is it'll probably be around like 2 or 4 micrograms per mil. And then, so yeah, for the Northwest substituent, I had just proposed a couple compounds that build on the active one, the diethylamine. The morpholine, I think, probably is especially interesting because we do have a compound where that morpholine is directly attached to the core. It's not active, so I think it could just be a nice little SAR point to say that when you do have the phenyl, then that's going to end up being crucial for activity if this compound is active. And then one other thing that I was noticing is that we've got all these phenyl derivatives, but we don't, the only heterocycles that we really have are these fused ones up in the table above. So we don't really have just any pyridyl or pyrimidine derivatives there. So I thought maybe, if we wanted to expand the SAR, but like I said, I'm not sure necessarily that that's going to buy us much in terms of potency. And then the Southwest, so yeah, I think we've pretty well established that the 2-pyridyl is essential for activity. So that's kind of nicely shown, I think, in the points well made in this table. And so my only suggestion here would be to dig a little bit more on this substituted pyridine, which does seem to retain some activity. So these ones, I was wondering if maybe you guys at Northeastern might have already made these, in which case I think they would be really good to test. And then if not, maybe we could make them, maybe not. We'd have to have a think about whether we think that that's worth it.
I don't. We actually have 100% made those. I'll see in our stocks today. Yeah. I'll have a look in our stocks and see what we have available.
Okay, amazing. Thanks, Quillon.
Have you made the compound where you've got the methoxy is replaced by dimethylamino?
You sent us,
Yeah, I feel like we might have sent you one of those.
But it's not, it might not be exactly matched back to anything that we could compare it. So in that case, it's a bit less useful for.
Yeah, I'd have to double check the substitution on it.
Okay, yeah, if you've got anything matched to like, I would say 987 or 1001 with the substituted pyridyl, that would be, I think that would be interesting to test. Or, we just kind of build out the SAR, sorry.
Yeah. The dimethylamino, of course, would make that pyridyl nitrogen a bit more basic.
You're attaching DMAP to the molecule there, Chris.
Yeah.
Yeah, that's right. Yeah.
Just the magic ingredient in lots of chemical reactions.
Yeah, well, if it's tolerated, it might also make things a bit more soluble as well. So you can perhaps look at other areas of the molecule and not worry so much about lipophilicity.
Yeah, without knowing 100% what the substitution was, whether it was the 4 or the 5, the dimethylamino did cause about a 10-fold improvement in solubility for us.
Yeah, so at this point, that really is looking like kind of the only place to go in terms of this 2-pyridyl substituent. So then the core, that's interesting. So basically the top 3 on the left-hand table, or sorry, the 2nd, 3rd, and 4th, the ones that are highlighted. These cores have been made, but the substituent on the Northwest is one that we found was inactive with any of the active cores. So then, of course,
that was the benzodioxazole dioxane.
Yes. So that Northwest substituent is not active even when there's a good core on it. So we can't really build out SAR from those molecules because I wouldn't expect them to be active anyway. So I think that's caused basically by the Northwest substituent, not by the core. So these are ones that I would just, we have data on with this other, Northwest substituent, but might be useful to do it with the paramethyl. And again, the 5,6 aromatic core with the paramethyl is one that would fit into this table as well, and then also be maybe a bit useful because we have these substituted versions of the aromatic one. And then the bottom two are cores that we have, again, on other compounds that aren't necessarily matched back to this. So I just thought it might be good to get them all in one table, but they're, you know, highlighted in yellow because we can still make the point without having these analogs necessarily. So it's just a question of whether we want to expend that synthetic effort. And then on the right-hand side, this is a kind of a similar core exploration with the NH linker analogs. So these will all be the 5,6 aromatic core, just substituted differently. So we've got the substituents at the 5, 6, and 8 positions, but I couldn't find ones that were matched back to with the 7 substituents. So again, Quillon or Lori, maybe that's something that you guys already have. And we could just test them and kind of slot them in here.
Check and see what we have available.
Okay. Yep, and then these, the inoculations, is kind of a nice little table. I mean, I think it's, you know, pretty complete. There's nothing obvious that's missing from this. I don't think it's a nice little demonstration of that. So I think that that's fine. And then these guys, so I kind of was able to fit the amides in here. So again, this compound in green, then we would have a whole row complete where we have the direct attachment, the NH linker, and the amide linker, which I think would be a nice thing to show in a paper. And then if we wanted to fill in the bottom row, that might be nice, but you know, if we make this compound in green, it's not necessarily necessary to make the point that we want to make about how this northwest substituent is attached to the core.
Could you go up to the table you've again above? I mean, you've got nice alkylations there, but they're all just hydrocarbon. Have we made any where we have polar heteroatoms in them?
No. Have you guys at North? Have you guys made? Lori, I think you said you were working on the oxetane, maybe. How's it going?
Yeah, the alkylation to access the heteroatoms in that has been a little bit more tricky.
Okay.
Okay.
It's mostly the purification that's the issue with that.
Okay.
What if we put something like, I don't know, something like MomCl or some sort of, you know, like oxygen in the chain somewhere.
Yeah. It does look like you've got some space there anyway, given that you've got the cyclopropyl methyl in there. So, you know, maybe that is one of the positions where you do have room to try and manipulate the physical chemical properties and also look for another interaction.
Yeah. Cool. And then the bottom two is just kind of like a bit more miscellaneous. Like I couldn't fit them really into the tables above, but you know, maybe there's something to be pulled out here. Those ones I wasn't quite sure how useful. So the ones in the table, there's some activity. The ones that are down at the bottom are all inactive. So that's kind of that part. And yeah, that's it. And then at the bottom, I just sort of summarized basically what I talked about throughout the tables, which is the sort of the gaps that we need. So these are the compounds that I thought maybe you guys would have at Northeastern. This high priority one is obviously the one in the green that would fill in kind of some of those boxes. And then the other ones are just the other ideas that I had that would maybe fill in some of the tables a bit more. So yeah, that's that.
That's a really nice summary, Dana. Really good.
Yeah.
Thank you.
Very useful.
Yeah. So yeah, and again with just the caveat that any of these proposed compounds, I don't really think will be will buy us, a ton of like be a breakthrough in terms of potency, but it I think they'll help us tell the story. So that's why I sort of propose that we make them.
Yeah. All right. I mean, I guess that high priority compound looks pretty simple to make. I guess the question of which of these can be dealt with existing compounds from Northeastern is then the second question, and we can take that offline and just take our time with analyzing, what might be available. The homologous compounds from Flavio and Daniel, I guess we'll also add a new thing in here, which we don't currently have, and that's fine because it's a new departure, right? It would add an extra little element, which makes a lot of sense. The question is then of the others where we don't have an immediate solution, which would require some resources. We just have to make a decision about whether we go down that road. I guess the order I've just said them in is kind of the order of priority, right? I would agree with you with that high priority compound up the top left there. So if you'd asked me, I would have said, of course we've made that.
I know, yeah. It's kind of crazy that we haven't, but we haven't.
Okay. So Quillon and Daniel, did you want to say anything about compounds that maybe are available or which are potentially incoming before we finish with this part of things?
Yeah, for sure.
Yeah. Okay, sorry. I thought it was me.
If you want to go first, Daniel, by all means.
I just have a few things to say. I tried the reaction with bromide. If you remember, someone suggested to me instead of trying to do the inoculation with iodine, trying to bromide. Seems that the reaction works and purification is not that hard. I got just the start material and the product. And also I did inoculation start from the aniline. I did the inoculation with aniline, and then I'm gonna do the next step to have the final compound. But the problem is we have some new plans. I was out of the lab the last 2 weeks because I'm writing a proposal to go to work with Professor Matt. We finished the project, but I find out I need to write a report as well. Before I submit the proposal, I need to present a report. I'm about to finish the report tomorrow, and I hope to go back to the lab next week, and then I can keep working the synthesis, because the last 2 weeks I was actually working all the documentation. There are many documentation that I need to provide for this proposal. And if everything works well, I'm gonna go to London at the end of December. So then this project would be my main project, and I would have time to work on in this project, and I guess would be better than split my time in many projects, because here I'm involved in my project as well, other students' projects. Let's see if I can make progress in the next weeks. Okay.
I mean, just on that, if we assume that we make the high priority compound that Dana talked about, that's going to take a little bit of time. Let's pretend we're going to make another couple. Let's pretend that there are some compounds that need sort of shipping around. I can imagine that we would have an evaluation of some compounds again by Paul, maybe sometime this month. If you're able to get one of the homologous compounds or one or two of them by then, sometime, then that would really fill that part of the SAR and let us know if it's worth making more there.
Yeah, I will try to finish at least like 5 compounds. I have two already, and then I can ship them, because it doesn't make too much sense increase the set of compounds if you don't know if that linker would work for activity.
Exactly. Yeah. I mean, I think the disproportionate benefit, if we could know that in the short term, rather than make lots of compounds in the long term. I guess I'm just thinking it would be helpful addition to the SAR table. Okay. Great. All right. Thank you.
Thank you.
Quillon, did you want to say anything about the?
Yeah, I've actually got a quick little slide.
All right.
I'll quickly share. So these are the compounds. So we currently have a couple of rotating grad students and 2 undergrads in our lab at the moment. So we've got them working on finishing off a couple of these compounds that I talked to Dana about. So on the top row here, we have the unalkylated form of these. So if you have a preference over having this alkyl chain installed or just the methyl, it's not too late to have either or both. But the one in red needs to be the core of which needs to be resynthesized, so the free NH of that compound. But all the others we have in stock and are available to be alkylated. We're also going through and making these bottom compounds here. So for these, we need to synthesize. Just go to the next slide. We need to synthesize via Suzuki the actual aminopyridine, which I think all three have been made now, or at different stages of purification. And then it's just the synthesis of the isocyanide and then the three-component reaction followed by alkylation to access those. So that might provide an avenue to sort of test some substitution in the actual core itself, which is what I think I saw in your slides or your little summary, Dana, that you were interested in. But in addition to that, some direct holes have been synthesized. So I've got these compounds ready for shipment currently. So we could send them with the other compounds that are currently in the progress of being synthesized, or if there's a need for them to get into the next testing cycle, we might be able to send those earlier as well. So that's where we're at with compounds that are currently getting synthesized. A few of the compounds, as I sort of mentioned when Dana was going through it, we have previously synthesized in the lab. And Laurie just sent me an email with a quick summary of what we have in stock. Bear with me here. So just scrolling through here is I'm not sure if I'm showing.
We can only see your PowerPoint.
Bear with me. There we go. We're seeing all that now?
Yeah.
All right. So these are compounds that we may not have in.
Hold on.
Is it showing?
Zoom in. Make it bigger, please.
Tell you what, that isn't going to work.
All right, it'll be fine.
Hang on.
Needless to say, while you've been talking, I've been looking at our database. It looks like we have some of those compounds available.
The size was fine, I think. Just show that message. It was fine.
It's the green that hurts.
Yeah. If you guys want to keep ambling in the background, I can quickly pull some up.
In terms of the
unless you still have it open on CDD, Larry.
I've got, yes, I do actually.
You might be able to make the images larger with that.
In terms of the alkylation thing, if there's a choice, then I guess we would go with the alkyl chain, not the methyl, right? Because we've just seen better activity with those. If it's all the same.
It's all the same for us. In fact, the longer the alkyl chain, the easier it is to purify.
All right, I'd go with that.
Okay, so in terms of, I think I've got this right, Dana, from what. So unfortunately, we don't have any of the kind of, we call it para to that nitrogen. We don't have any of those available in stock at the moment, but it's something that we have another 2 graduate students going to rotate through in a couple of weeks.
Oh, there it is.
This is that.
Have you got enough of that to put an alkyl group on the nitrogen?
This one, NE6672, this one?
Yeah.
So we need to double check. Usually, because Quillon has remade it, I'm hesitant to say that we actually still have this in stock. We may have sent this somewhere at some point.
Well,
but we
if
can
get resynthesized, we would probably methoxy off of the core.
Yeah.
Right, what was that, Anthony?
That one has a methoxy on the core.
Dana was talking about in terms of having the methoxy off here, no?
Well, didn't it in one substituent have? I don't have the SAR data up.
I think the methoxy is not necessary, but it's more of a question of what we have available.
Yeah, so well, hang on. It's
We should have it without as well.
Okay.
yeah, right, Quillon?
Yeah, I'm 90% sure, no matter what it says in CDD, but I still have some of it.
Yeah, just the thing about that methoxy is that I think what the problem with it is that it's never actually been isolated as a change on its own. So we just wouldn't be sure whether that's like doing anything for us or whether it's basically whether it's beneficial or detrimental. And so then it just becomes a bit harder to tease out what's actually happening with whatever substituents on the pyridol. But that doesn't mean we can't test them and see if they're interesting.
It looks like you don't have any material anyway, so.
Quillon was just saying that might not be necessarily true.
For example, 6924, 6924, for example, whenever it's destined to be alkylated, I don't list in CDD that we have, or in our database that we have any available, because 9 times out of 10, I tend to use all of it. But I might hold back like a MIG or two, enough for like one more testing round, just in case. So yeah, if it's a free NH and it says 0, there's a small chance that there's some left. If it is alkylated and it says 0, there's 0 chance that there's any left.
So, I mean, it looks like we don't have a whole lot of these, but if they work with the story in terms of, they together, we could certainly look at putting the rotating grad students onto making those.
Putting the alkyl chain on that nitrogen, Chris, on that one at the bottom of the screen that Laurie just had, is that easy given that you have, given the number of nucleophilic nitrogens in that molecule, is that going to be an easy reaction to do that alkylation?
No.
Yeah.
No, the reaction goes, just the purification becomes a bit of a nightmare, but it's doable because we've got it out. So it just means that we might have to run a couple of preparative HPLCs to get it out, but that's not an issue.
Yeah, evaluating the NH compound, I'm just not sure it's worth it without something on that nitrogen.
And again, like I'm talking in reference to the methyl. Whenever I've made any of the compounds with a longer alkyl chain off the nitrogen, the purification becomes a little bit more simplified.
Right.
So yeah, so it seems like actually the methyl is a bit worse than either the NH or the others with the longer alkyl chain. So I'm happy to avoid the methyl.
Right. Okay, that would be a nice compound, but yeah, see what's involved in making it. It's a neat suggestion. All right, well, it looks very good. And thanks for that. I guess, the ones that you think are available, if you're able to dump that deck, Quillon, in the GitHub issue, then we can have a record of what's available there and then think about what's going on. Again, the time scale of a few weeks, I guess, is what I'm thinking for the next evaluation, whatever we have by that time. Because Dana's, picked out some things that we should look at it in the short term, I guess. I don't want us to be hitting our heads against a wall and making lots of compounds when we can't break through that potency ceiling, but there is an argument to doing these exploratory things to make a more compelling story. All right. Well, thanks for that. It's very interesting. So we were here. So yeah, any other thoughts here and availability of compounds, just dump them right in here. All right. So those are the main things, I guess. And it's really nice to have that kind of short list of compounds. So I get, we don't have Alex on the call, right? But we hope that she is still working on her final tox report.
Yes, I've emailed with her and she will be here either next week or the week after. I just have to confirm, but she's back from her holiday now. So I'll let you know.
All right, thanks. And yeah, I've been in touch with Lee Graves about doing parallel MRSA lysate experiments and human mechanism of action experiments, and he is now aware that there is money at UNC to support this project if he needs it. I mean, that's what's been supporting his mechanism of action experiments so far, and so some of that could be used to recompense any lab that provides MRSA lysate. So he's gone back to his colleague and he's seeing if he can work out a way of doing that. As of a few minutes ago, I don't have an email from Lee, but I'll keep on chasing him. He has the compounds to hand. He just needs the MRSA lysate, and then he can do the 2 parallel experiments. I think this is the most crucial thing that we have to do. And without MOA information, I'm hesitant to spend too much more time looking at compounds, because there comes a point where you have to say, well, we're not breaking through. But with mechanism of action, we might be able to do something. All right. And then, I mean, anything else that crops up from the last meeting, we can discuss. I mean, these are obviously what we just talked about, the most important things. I noticed though in the last one, the last meeting, Dana, you've ticked this off, which is great, about manual strings and lab archives. Is that because you actually did this?
But Ed's the one that did it.
Oh, right.
Right. And yes, kind of found out by accident that you can convert one of these little to-do items into an issue. So I did that and then closed it.
Oh, really? Oh, so you've done it and closed it. Oh, right, fine. Okay.
Yeah.
Wait, so it was number 90. So I can just go there, right?
Yeah.
Okay. Sorry, I forget what it said.
Yes. Yes. Yeah. So Ed says we still need the strings.
So Ed, can you just describe this? Sorry, because it's quite important.
Well, yeah, I don't think anything's changed since the last time I looked at it, but essentially if you use the structured drawing tool on lab archives, it won't be indexed by Google, so you can't search the strings if you only have that. So you have to actually paste the strings in as text to be able to find
Right. So the metadata, which presumably is in the lab network entry, is not Googleable.
Yeah, seems like that.
You gave it enough time between doing it and searching it?
Yeah, I mean, I can try again, but I don't think it's going to change.
Yeah, okay. Okay. I mean, it's something that needs fixing by lab archives. If we're going to continue to use lab archives, it's something that needs fixing because it's just too difficult otherwise. The idea of manually doing this was amusing 10 years ago. It isn't terribly amusing anymore. So it definitely needs fixing, yeah. Okay, but it's good that you've done that. Thank you. And then these other things, I guess we don't really have it. So this is just an issue to do with the how-to, Ed, about.
Well, I mean, I've never used it, so probably not the best person to do that.
I guess we just need something somewhere on a wiki that makes it clear that at any given stage, if we're thinking about molecules that we need, we always have to have one eye on what's commercially available at a low cost. That's all. So it needs to be just part of a workflow. In case people don't realize, that you might be designing a molecule that you can buy for $100. I'm just worried that it's not sufficiently high up on the workflow side of things. So, you make molecules when it's really needed.
Maybe, Anthony, is that what you did for the 2 amides? You used Manifold?
Yeah, I was gonna say I'll recover my Manifold account and run some stuff through and see what I get. But the thing is, everything seems to the first thing that seems to go out the window is the 2-pyridyl. Like, you can't find compounds that easily with the 2-pyridyl, but I will keep thumbing through and trying.
Oh yeah, but we're also just talking about writing up a little bit of how to use it on the wiki. So if you feel like you would want to do that, then maybe you'd be the best person since you've done it before.
Yeah, so it's more you get to a point where you think, okay, given the molecules we want to make that we've designed, someone just has to do a check of what's available, and this is how you do that. in case people haven't done it before, right? So I'm thinking about newbies. So yeah, I mean, if you had the time to do that, that'd be really good. You know, just a page on the wiki that says how to search for commercially available versions of molecules that are being designed. That would be really helpful.
It's pretty easy. The Manifold app is very polished. It literally uses smiles strings just like anything else would. But I'm going to run something right now.
So if you're able to capture what you're doing and put it in a workflow, that would be very helpful. So for example, is Manifold enough? Should we be looking at other suppliers? What's the difference? Those things. That would be really helpful. And then the other thing is just why the OSM, we talked about this, but did we resolve that about why the Google Sheet isn't Google indexed?
Google doesn't index the contents of sheets.
Right. And there's a reason for that, is there?
I think sheets just changed too much.
Right.
I mean, people use them as spreadsheets for accountancy and things like this. So.
Right. Yeah. Okay. And the workaround is to make it static and then upload it somewhere.
That's correct. Yes.
So we would have to host a sheet somewhere where it's discovered, and then that sheet would have to point to us.
I've forgotten his name. Somebody did that. I can't remember his name.
Well, for us, you mean?
Yes.
Right. Okay.
Oh, yeah, it's gone. I can't remember his name, but.
Okay. So, I mean, if we,
it's
all right.
somewhere in the issues related to this.
If so, it's frustrating though, right? Because it's manual, and the what you'd want is an automated process. Otherwise, people are going to go mad. So you'd want it to export somewhere where it's discovered, and there's a link between that site and what we're doing, the live version. Was it Jensen? No.
No.
Okay.
Will was it? Someone like that? I can't remember.
So I don't have a good solution to that, and it seems a shame because of course we've got all the smile strings in there, and that would help us to be discovered. I just don't want to have to rely on someone doing a manual export. Ideally. I mean, then it's a batch-wise process, and someone's got to remember to do it, and that just makes me shiver with horror that someone would have to incorporate that into what they're doing. But it could be a quarterly thing. I mean, that's what Kemble does, right? They have periodic batch uploads.
Well, Kemble, it's years. It can be years between them, but yeah, we want it a bit more often than that, I think.
Yes. So the thing you want is some way of periodically backing it up. I mean, I guess if you took it as an Excel sheet and you put it on Lab Archives, I imagine it would be found there. I imagine, because it's a sheet, right? I imagine that would work, but someone's got to do it, and it's just makes no sense. With Laurie and Quillon, you're using obviously you're using CDD as your compound registration system. So if you, if that is open, can it be found via Google?
Question. So there is public repositories, and so you can actually just make everything live. I actually don't know how you search that public data though, specifically.
To see it, you still have to log in.
I think you could create a free account.
But you have to log in to see any data. Because if you do that, it'll screw up the Google indexing.
Yeah. I mean, I can ask them, but yeah, I don't.
Yeah, I'm already talking to them about this in a hypothetical level. I guess I was wondering in your particular case if that was something that you'd seen or would be useful. Because then that solves it, right? Because you don't have to make special arrangements for things to be found in a different way. All right. Well, I'm talking to them about this issue. It'd be interesting to see what your experience is like, and if there's any better way of doing this. You know, we're using a Google Sheet because it's just so low tech and simple. It's not a compound registration system, but it's part way there, and has the advantage of being straightforward and free.
Yeah, I'll have a word with the data warrior folks, because I mean, it's easy to write a macro that will import the data into data warrior. I don't know whether they can have that macro could then export it to say an HTML page. It would still mean somebody would have to press a button once a week or whatever.
Yes. Yeah. Okay. Anything that simplifies, the ability of people to discover these molecules, basically. I mean, because we're missing a trick here, I think. Yeah. So that, yeah, anything you can get from that would be great. Yeah. So understanding what CDD is able to do and understanding what data warrior are able to do, that'd be really fantastic. Yeah. Thanks very much.
I know you set CDD to automatically export your library as a PDF, and maybe you could utilize that. But whether or not we tend to keep all of our libraries private, so we haven't had an opportunity to share them publicly. But I know you can set in the background automatic downloads of your inventory of compounds.
Right.
So that might be a way to get around it if you want to go down that avenue.
Right.
But I'm sure they have a more sophisticated way than exporting images.
Yeah. PDF is not the ideal platform for this sort of making it publicly accessible, is it?
So that's a very nice way of saying that if you talk about doing PDFs in the cheminformatics community, you get howls of derisive laughter. Yeah, it's funny because it's what we use for sharing things like, images of NMRs and things like that, but it's dead data essentially, and you can't do anything with it. So it would be nice to try and keep it live rather than PDF. But I understand what you mean, Quillon. Yeah. I think Peter Murray Rust used to call PDFs hamburgers.
Something like that, yeah.
Yeah. So all the genetic information is dead or something. Yeah. Okay. That's everything I had. Really, I want to sort of focus in on the SAR stuff. That's been very productive and helpful. Is there anything else anyone else wants to mention briefly? All right, great. Thanks so much for coming, everybody. Really useful discussion. And we'll take up the rest of this on GitHub.
All right.
Nice to see everybody.
See you then. Bye.